So we're getting very close to doing some problems with these ideal gases, but first we just want to just go over ratios, unit conversions, I should say. These are in your data book already, and these ones aren't, but they pop up all the time. So in Australia, at least they always do it with this weird unit that's not really used. These ones seem to be a lot more popular, atmosphere and millimeters of mercury. And so if I looked it up, there's this here. So I'll just ask for both so you can get a bit of practice and so show how you do ratios for unit conversions. And so we have this, so we write down one of them. So we'll do atmospheres first, because then we're going to go for atmospheres to millimeters of mercury. So there's the ratio. 1 atmosphere is to 113 hectopascals, and so X is to 106. So we're trying to work out how many atmospheres this is. So we cross multiply and then divide both sides by this number here. And so 1,006 hectopascals is 0.993 atmospheres. Now that is not the correct sig. Oh yeah, it is. Okay, and that's all fine. And now we're going to convert to millimeters of mercury. So same deal. You write down your ratio, you write down your x's, you cross multiply, and then you solve for x, and there you go. So it's wow, what is that? 100.6 kilopascals. So that's how you use ratios. So obviously we've used ratios a lot for gas stoichiometry and for all the other stoichiometries for step 2. And now this is how you use ratios for unit conversions. And so we're almost there. So the only other thing we need to know is that you can combine all those 3 gas laws into one. So this is in your data booklet. So pressure times volume equals number of moles times gas constant times T. And so the only thing that's constant in here, so we can change pressure, volume, number of moles, and temperature, but the gas constant, which is here in your data book as well, is the thing that we combine to the constant. So that's PV on NT. So as we saw before, any situation of these will give us a constant. So pressure, volume, number of moles, and temperature in one situation will equal the gas constant, which will be the same as pressure, volume, number of moles, and temperature in the second situation. So you might have a question that's horrible and it's changing all of these, or you might just have some of these as constants, and if they're constants, you can just cross them out. So you get V1 on T1 equals V2 on T2, or maybe you're just looking for this, P1 V1 equals P2 V2 if the temperature and number of moles are the same. So basically all you need to know is this, that converts to this, and then you just cross out the bits that you don't need. And so you're done. So you're good to do an equation, do gas law equations, almost. So you got to also remember IB uses metric. So if I just clear the slide now and just look at the units, you need to make sure that you use the correct units. Kelvin's fine, and the gas constant is fine, I think, and number of moles is moles, obviously. These two are sort of the newish ones. And so how do you convert to meters? We're using meters cubed and pascals. Now, a lot of textbooks use kilopascals here and decimeters cubed, but you're not to use that. You're to use pascals and meters cubed. And you're going to find it actually one's dividing by 1,000, one's timesing by 1,000. So if you're going from kilopascals to pascals, you're going to be timesing by 1,000. And if you're going from decimeters cubed to meters cubed, you're going to be dividing by 1,000. So that it ends up being the same thing as long as you're consistent. So most textbooks and syllabuses use this, but IB uses pascals and meters cubed because it's metric, which is technically the correct thing you should be doing. So you're aware of pascals already. You might not be aware of this one here. So there is 10 decimeters in a meter. And 100 centimeters. And so 10 times 10 is 100 decimeters squared in a meter squared. And 10 times 10 times 10 is 1,000 decimeters cubed in a meters cubed. So if you have, so that's the ratio, 1,000 decimeters cubed. So that's working from first principles is to a meter cubed. And so if you have 1, how many meters is it? It'll be 1000 x equals 1, and so x will be 1 divided by 1000. So it's always divided by, so that's working all the way back to first principles. So if you're converting decimeters cubed to meters, you're going to have to divide by 1000. And so hopefully that makes sense. So as long as you understand that this is the much, much larger one, and so if you're trying to say decimeters to meters cubed, it's going to be a smaller number than what the decimeters cubed number was. Okay, so we can do calculations now. I think we've got all the formulas and units and conversions worked out. And so the first one here is we have to sort of work out what we need and what we have. So we have 3 atmospheres. So the pressure. So we have a pressure of 3 atmospheres, which we can leave it as that unit, and the volume is 2. And I'm going to leave it as that unit because the IB doesn't give you a conversion in your textbook. So the new one is 1 atmosphere. So what's the new volume? So PV equals nRT. So P1V1 over N1T1 equals P2V2 over N2T2. We haven't had any temperature changes. We haven't had any mole changes. So that's the formula we use, and they're the numbers we sub in. So that should be what's going on. Yes, P1V1, P2V2, those numbers, and 6 centimeters cubed. We didn't need to do a conversion because we're not asking for the pressure. I would have left it in atmospheres anyway. Moving on. Okay, so this one here, I think we're changing everything for this one now, is it? We've got volume, we've got temperature, which needs a conversion, pressure, which needs a conversion. Okay, we're going to have to do a conversion for this one because we're using the formula with, and they don't cancel out on either side. And so let's do those conversions. So 1.5 times, so you have, go back to your conversion chart, maybe learn that just before the test because that wasn't in your data booklet. So converting the atmospheres to pascals, divide by 1000, converting the decimeters cubed to meters cubed. And this one is in your data booklet. So to convert Celsius, you just add 273, and that's the Kelvin there. Okay, so we're using all of them now. So PV equals nRT, subbing all those values in. And we work out that, I didn't even read the question, by the way. So what are we looking for? Number of moles of hydrogen, and n's what we get, number of moles of hydrogen. Okay, so you can do that in chemistry, unfortunately. You can actually delete all the English words and still get the answer. And there you go. So there are practice questions. Now is the time to do all the different practice questions now that you can use PV equals nRT to get the correct formula for everything.